Assalamualaikum warahmatullahi wabarakatuh. My name is Nuri Syahada binti Musa, and I will presenting about the schematic control diagram for main incoming of low voltage distribution design. Okay, as we can see, the figure here, figure 7.3 show us the schematic control diagram for main incoming. Okay, as you can see, we start from the incoming supply. The condition of this schematic control diagram is it is three-phase. The frequency is 50 Hz. The voltage is the ratio of the voltage is 415 dash 250 volt 240 volt. This is in for the common voltage supply in Malaysia, and also it is in AC supply. So from here we have actually there is four. This three is for red, yellow, blue, and this one is neutral connection. Okay, we go to the current transformer. So this is step down transformer. As you can see, there are 3 times 150 dash 5 ampere, which is this step down transformer. The function of transformer is used. The transformer is used to measure the current of another circuit. It's also produce an AC or alternating current in its secondary winding that is proportional to the current that it is measuring in its primary. Okay, so from the transformer we go connected to the kilowatt hour. Okay, as you can see here, kilowatt hour. Okay, from red, yellow, blue, and then it connected to the kilowatt hour. The function of kilowatt hour is calculate electrical energy consumption in binding cycles, and then from kilowatt hour it connected to the MCB. Okay, this is MCB from red, yellow, and also blue. The value of this MCB is 6 ampere. The function of MCB is to protect an installation from overloading, and also protect from short circuits fault. It also protect from earth fault. Okay, we go to the upside. Okay, and then they are also here the same value of MCB, which is 6 ampere. MCB is actually a short form of the MCB is actually the short form of manufactured circuit breaker. Okay, as you can see, you can see this is the main supply, MCCB. Then we go to the ups. Also, we meet MCCB again, and then we go to the upside. Actually, there is a switch here. Okay, the function of switch is for main supply. It is for connecting and also stopping the electric current in the circuit. Then we go up. It connected to the. Okay, as you can see, we meet. This is air circuit breaker. As you can see, ACB, air circuit breaker. And then we meet current transformer again. This one is the ratio of the step down transformer is 150-5 ampere. Okay, at this point we use 4 transformer. Okay, and then we meet this is as you guys can see, this is IDMT. IDMT stands for inverse definite minimum time. Inverse definite minimum time. The function is to protect feeder against fault involving ground. Okay, so you can see that there is 3 overcurrent, and 1 earth fault. Okay, and then it connected to the again transformer, current transformer. The value is still the same for step down, 3 times 550-5 ampere. And also, okay, this is we have ammeter here, which is ammeter used to calculate current, to measure current. Okay, as you can see, this is power factor correction. Power factor correction is important. The function is used to this power factor used to improve power factor and also power quality of the overall circuit. The benefits, the advantage of power factor correction is it reduce load. It also increase energy efficiency and also reduce electricity costs. Okay, and then we go upside. This is 1 times also the same amount of ratio step down transformer 150 and also dash 5 ampere for current transformer. Okay, we move to the up and then we meet also MCCB, the same value 6 ampere. Okay, and then this voltmeter, the value of voltmeter is 0 until 500 volt. The value the function is to measure voltage in the circuit. Okay, so this is the bus bar supply, which is the function of bus bar supplies. It is used to connect high voltage equipment, electrical switchyard, and then as we can see here, okay, back to the down. This is actually a single phase current transformer. Okay, and then it connected to the here main bus bar for red, yellow, blue, and also neutral. Okay, I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So, my name is Nurul Iwanina binti Muni Irawan, with matric number AE 180080. So, I will explain about the schematic control diagram for outgoing feeder CW earth leakage relay. So, basically the earth leakage relay are designed in such a way that whenever they sense a preset value of the current, it will trip the circuit breaker and interrupt the flow of current. So let's see how the circuit flow first. Okay, first, it start from incoming from main bus bar with 415 to 140 volt, 3-phase forward 50 Hz AC supply. So we see, let's see for the red phase. So from the red phase, it flow to the MCB and straight away go to the relay. As we can see here, the relay is in open state. So when the relay is in open state, the tapping of current transformer here, full current transformer will receive a magnetizing current. Then it will produce an output, and that output is required to operate the relay, and the overcharged current will flow and trigger the relay to be in closed state. After that, the signal will pass to the shunt trip here to open the MCCB. Therefore, the circuit will cut off the power supply and the component will be protected from the overcharged current.
Assalamualaikum, my name is Fatima and I will explain about figure 7.5, the schematic configuration diagram for outgoing feeder CW earth leakage relay. As you can see here, first, the incoming supply is from the main bus bar with 415 to 150 volt, 3-phase forward 50 Hz AC supply is supplied to the load. And as you can see here is the 60 ampere TPN MCCB. And up here is the ZCT. It's for the zero current transform. And here is the phase, the RYB, and the red, yellow, blue, neutral. And as you can see here is the ELR, the earth leakage relay. So the function of this relay is to find the leakage current. So before leakage happen, the incoming and outgoing current are equal. That means the vector sum of the 3-phase current is equal to 0. But what will happen if there is leakage happen, and that's when the ELR here will trip and it will make contact. When it make contact, it means that the current, the outgoing, the incoming and outgoing current is not equal to zero anymore. And as soon as the the value of the incoming and outgoing current is not equal to zero, it will trip the ELR here, and that means as soon as the leakage happen, it will trip the ELR, and the response time exceed the level. Then, uh, when the ELR trip and make contact, the MCCB here will trip after above signal pass to the shunt coil. That will happen, and so when leakage happen, the ELR will trip, and then it will and the MCCB will automatically trip it. That means that the MCCB here will not make any contact. So that's all for me. Thank you.